All right, this is the video for lesson 4.4, the slope of a line. And slope is something you probably studied last year, if not in years past. And so slope is a comparison between the rise over the run of a graph. And so if we have ordered pairs, we look at that as y2 minus y1 over x2 minus x1. And we're going to look at how exactly to make those calculations here in a little bit. So if you look at my first graph here on the left, I am counting my rise over my run. And so I'm going from the bottom left point to the top right point. So my rise I wrote in red, and I count each line as 1. So I'm rising 5 points, and then I'm running to the right 3 points. So my slope for that particular line is 5 over 3. Do not simplify that. Do not make it into a mixed number. We want to leave it improper because we want to see a clear comparison of the rise to the run of a graph. In example number 2, again, I'm going from the lower left point to the top right point, and so I'm going up 6 and right 3. So in this case, I have 6 over 3. Now, because that does simplify to a whole number, I do want to simplify it to either 2 over 1 or just 2. Either one of those answers is completely acceptable when it does simplify to a whole number. Now, of course, with all fractions, if it is able to be simplified, we want to do that. So, for example, if it was 10 over 6, we would want to simplify that to 5 over 3. We don't want to leave it unsimplified, but we do not want to put it into a mixed number. All right, so both of these lines that I have drawn here are positive slopes because positive movements are up and right. So anytime we go up on a graph, it's a positive. Anytime we go to the right, it's a positive. Then that would mean that negative movements would be down and left. And so we can look here at this graph, and we could go from this point here down to that point. It would be a rise of -6 because I'm going down, and a movement left of -3. So -6 over -3 would be +2 still. So that would make it, the down and the left are negative movements. All right. So if you have a negative slope, one movement must be negative, the other either down or left, and the other one is going to be positive. So let's look at a couple lines that have negative slopes. So here, this case, example number 3, we go down 5 units and right 2. Because the downward movement is negative, I have -5, and then moving right is positive, so it's -5 over 2. Example number 4, I can start at the top left point and go down 3, and then right 5, and negative would be the downward movement and the right would be positive. Or I can go up 3 and left 5, and so that movement to the left would be negative. So either way I look at it, my slope there should be -3 over 5. Okay, so lines that go down and right are negative, lines that go up and right are positive. So if we read this as a book, going from left to right, like we would read a book, if it goes down, it's negative. If it goes up, it's positive. Okay, so how do we calculate slope using ordered pairs? Well, here's a set of ordered pairs, example number 5, and we take our y2, oops, it moved on me. We're going to take our y2 minus y1, so 5 minus 4, and I write that in the numerator, over our x2 minus x1, which would be 2 minus 6, which would be -4. So 1 over -4. Now, it really doesn't matter if this is y2 or y1, as long as if this is y1, then this has to be x1. You can't mix up the 1s and 2s between ordered pairs. They have to be the same one. So here I took this as y2, -1 minus y1, which is -2, which equals +1, over 7 minus -3. And so I have the slope of 1/10. Here's example number 7. Again, This I took 0 minus -1 over 2 minus 5. This double sweeps and becomes a positive 1. 2 minus 5 is -3. So the slope here is -1/3. All right, that's all I have for you for tonight. Make sure these problems are done and have a good night.